All right, there was a question about number 8 on the summative review, and somebody asked me to work out this problem. So I'm going to work this out for you, but this is the hardest problem on this summative, in my humble opinion. It's the hardest problem. So the table gives us values of a differentiable function f and its derivative at selected values of x. So let's just make sure I understand that. So when x equals 0, f of x is 3, f prime of x is 0. Okay, I got it. I don't have to study the patterns here, but I just want to make sure I understand the table that they're giving me. Now they tell me that h of x is equal to f of 2x. Okay, so that's kind of interesting. Which of the following statements must be true? Well, the first one, let's just go through each of these three statements and see if we can figure out what's happening. The first one, h is increasing on the interval from 2 to 4. Okay, so this is going to be like my chart. This is going to be the derivative chart. So I'm just going to put chart there. Number 2, because the derivative chart, h prime, h double prime. I'm going to have to use my chart there. The second thing, or the second bullet point, says that there exists a c between 0 and 4 such that h of c is equal to 12. So that's an intermediate value theorem problem, an IVT, which we'll talk about. And then part 3, there exists a c between 0 and 2 such that h prime of c is equal to 3. So that's a mean value theorem. Well, in order to prove the intermediate value theorem and the mean value theorem, I got to know that the function is differentiable and continuous. So what they didn't say anything about continuity, but they said differentiable function f. So if f is continuous, that means f of 2x must be continuous, which means h must be continuous, differentiable. If f is differentiable, then f of 2x is differentiable, then h is differentiable. And if a function is differentiable, it must be continuous. So I met the qualifications for the IVT and the MVT. So let's talk about bullet point number 1 first. All right, and we said we have to use the chart. So the chart says h prime, and h double prime. So if I want to know if h is increasing, that means I have to prove that h prime is 0. H prime is positive. So can I show that h prime is positive from 2 to 4? I really can't, because I'm given a discrete table of values. So what's happening at 2.5? What's happening at 3? I don't know. I can show that h is positive at 2, possibly. I can show that h is positive at 4, but I don't know what's going on at 3. I can't prove that. So because of that, because I can't prove that h prime is going to be positive from 2 to 4, because it could dip below the negative, I just know it's continuous and differentiable. I don't know that it's always positive. So therefore, this one is out. And hopefully I made a convincing argument to you about that. So that means that part B is out and part D is out. Now, if I'm running tight on time on a test, then now I've narrowed it down to a 50-50 guess. So that's better than a 25% chance of getting it right. So 1 is out. So let's now go to the intermediate value theorem. For the intermediate value theorem to exist, I have to evaluate h of 0 and h of 4. So h of 0, so this is going to be part 2. H of 0 is going to be f of 2 times 0, which is f of 0. And according to the chart, f of 0 is equal to 3. Okay, that's fine. Let's find h of 4. H of 4 is going to be f of 2 times 4, which is f of 8. And according to my chart, f of 8 is 13. So let's draw a picture of this to help you really understand what the intermediate value theorem is saying. It says at 0 and at 4. At 0, the output is 3, and at 4, the output is 13. So I have this function, I guess I'll graph it in green, that goes from 3 to 13. I don't know what it does. I just know it's continuous. I mean, look, it could go, to prove my point for part 1, the function could go like this. It could dip below and then come back up and do something like that. I have no idea. But I know at some point it must pass through 12. It has to pass through 12 if it has an output of 13 and it's continuous and differentiable. So that's true. Number 2 is a yes. Okay. So and then again, to prove my point with number 1, it could do this between 2 and 4. so I can't say that it's always going to be positive. All right, so 2 is a yes. So let's go on to number 3, the mean value theorem. So let's talk about what the mean value theorem says. We just did the intermediate value theorem. Now let's do the mean value theorem. So the mean value theorem says, and I'm going to draw a picture of this for you, that if I have, and they're talking about an interval from 0 to 2, 0 to 2, and it says h prime of c must equal 3. So there's some c somewhere between 0 and 2. It could be anywhere between 0 and 2, such that the derivative is 3. Well, what I have to prove then is that whatever this graph is doing between 0 and 2, and I don't know what the graph is doing between 0 and 2. I know I can tell you what the outputs are at 0 and 2, but I don't know what the graph is doing between 0 and 2. But so let's just say the graph is doing something like this. Maybe it comes down like this and does this. I don't know. But what I can say is that the average rate of change between 0 and 2, this average rate of change, if that average rate of change between 0 and 2 is equivalent to 3, then there absolutely has to be at some point an instantaneous rate of change of 3, and maybe that happens like right here. All right, so the instantaneous rate of change, which is there, that would be my C value, has to match the average rate of change between 0 and 2. So what I have to find is I have to show that the average rate of change between 0 and 2 is equal to 3. The average rate of change of h between 0 and 2. So let's find h of 0. H of 0, I think I just did that, is going to be f of, but I erased it, f of 2 times 0, which is f of 0, and f of 0, according to my chart, is equal to 3. And h of 2, which is going to be f of 2 times 2, which is f of 4, that's going to be equal to f of 4 is equal to 9. Okay, so now I got to show that for h of x, the average rate of change on the interval from 0 to 2, if that's 3, then this works. Then the mean value theorem is at work here. If it's not 3, then the mean value theorem is not at work. All right, so average rate of change of h of x from 0 to 2 is going to be h of 2 minus h of 0 over 2 minus 0. So h of 2 we found to be 9. H of 0 we found to be 3 over 2 minus 0. So that's 6 over 2, which is, it's equal to 3. Boom. All right, so this average rate of change is 3. And so there must be, since it's smooth and continuous, there has to be a place where h prime of c is equal to 3. So that's a yes. So therefore, I can say that my answer, without any doubt in my brain whatsoever, the answer is going to be C for this problem. And that's how that one works.